What I want to do today is looking at problems like this, where we have to use integration by parts, which is this formula here. So we might want to take notes from this point. So this is something that we did look at last year, okay, briefly. So let's review this technique. If you remember, the idea is to call one bit u and the other bit dv. In here we've got two parts, 5x times e to the 4x. So just like the product rule, in fact this method comes from the product rule, we have x appearing twice, so we know we've got two functions involving x multiplied together. So that's an example of where we're going to try and use the product rule. The integration by parts rule. Instead of it one bit equaling u, though, we're going to let one bit equal u and the other bit equal dv. So rather than u and v, we'll let one bit equal u, and we're going to differentiate that bit to get du, and then we let the other bit equal dv, so we're going to integrate that and get v. That's the method. And you remember that the point of it is let the bit we're going to equal u be such that when I differentiate it, the x disappears. That's how it works. If I differentiate, if I let u equal 5x, and then I differentiate it to put that in here to get du, then I won't have an x term anymore, and so I should be able to do the integral, the standard integral, hopefully. It gets complex when I've got, say, 5x squared here. Then I'd have to use it once to get rid of the 5x squared to become 10x, and then I'd use it again to get rid of the x. So sometimes you have to use this integration by parts method a couple of times, 2 or 3 times, to get rid of one of the terms. That's the way it works, by getting rid of one of the terms. So what we do is we let u equal 5x, and we let dv equal the other term, which is e to the 4x. So then, as we've let u equal 5x, we differentiate that to get du by dx equals 5. That's good, because now the x term has disappeared. And if dv by dv equals e to the 4x, then v equals the integral of e to the 4x, which is, you know what you do? The 4 comes out and goes underneath. Okay, quarter e to the 4x. So now we've got our two values. Yep. So now we've got the rule, integral of u dv equals uv minus the integral of v du. So the integral of u dv is our integral. In other words, I've let u equal 5x and dv equal e to the 4x. So I can say the integral of 5x times e to the 4x, which is what we're after, now becomes u, which is, aren't we? Yes, I am. Yeah. U, which is 5x, times v, which is 1 over 4 e to the 4x, minus the integral of v, which is 1 over 4 e to the 4x, times du, which is just 5 with respect to x. So now I end up with an integral that's doable, because x only appears in it once. So this equals, tidying up, 5x times a quarter becomes 5 over 4 x e to the 4x, minus, I can bring the 5 and the 4 outside the integral, e to the 4x dx. And so we've just got to integrate this again. It becomes 1 over 4 e to the 4x, doesn't it? So this equals 5 over 4 x times e to the 4x minus 5 over 4 times the integral is 1 over 4 e to the 4x. Yeah. And at the end, plus 6. I've left it like that because we can see now that the 5 over 4 can come outside the bracket, and so can e to 4x. So I can take 5 over 4 e to the 4x outside a bracket, leaving inside the bracket x minus a quarter plus c. That's all we're left with, isn't it? Yeah. So now, of course, remember this is actually a definite integral, so we don't need the c. We've got to put our limits in of 0 and 1. So I've got to let x equal 1, work out what it is, and then let it equal 0 and work out what it is. So I'll leave you to finish that off and see if you can get the answer in the text, which is 51.5, yeah.